Good morning, stats. We're going to move on to 2.2 here, and this is the relationship between two quantitative variables. So no longer categorical, we're dealing with quantitative where we actually have numbers involved. And this should be semi-familiar to you. We're going to use a little bit different terminology than we do in algebra, but it should be stuff that you've used, and I'm going to try to use that info or that language so you can kind of recognize it, because we have done this stuff before in Algebra 1 and Algebra 2. So moving forward again, relationships between two quantitative variables. Our objective one is to distinguish between explanatory response and response variables for quantitative data. So again, this is the whole X, Y idea when we're talking about explanatory and response. So when we have those ideas, we've got to make sure the explanatory variable is the X and the response variable is the Y value. Okay, so again, shows the scatter plot. We're going to deal with scatter plots in this section. We should be familiar with scatter plots, and scatter plots show relationship between two quantitative variables measured on the same individuals. Each individual is a point of the graph. So this is really important that every single one of these responses, these quantitative variables, is an X value and a Y value, okay? So we're going to identify the explanatory and the response variables. And again, sometimes that can be unclear looking at a scatter plot. So if you see here, again, the X value is the explanatory, which is the X, and the Y value is the response, which is the Y value, okay? And it's always going to be written as an ordered pair. So you can see we're going to talk about the association or the correlation of every single one of these points. We use the words association in statistics, where in algebra and algebra 2, we use the word correlation. So this graph right here, you can see that there is the explanatory variable is weight in carats. I'm assuming we're talking about some sort of diamond. And the response would be price in thousands of dollars. Okay, so we're going to distinguish between explanatory and response variables. So if you look at these two, we have two different examples, lifespan and heights. And identify the explanatory variable for the following relationship. So we're looking for what the X value would be. Okay, so this is saying the average income and life expectancy in a sample of countries. So is the average income or is the life expectancy the explanatory variable? So for this example, we would say that the explanatory variable is the average income, because depending on your income, we can probably draw a conclusion that you would live longer if you made more money, because you can have better health insurance, you can afford to buy better food, healthier food, you can afford to go to the doctor more, you can afford to see different doctors if you have more money. So the explanatory variable is the average income, because the amount of money people have to spend on healthcare, running out of room, healthcare helps explain, and this is really wordy, the average lifespan in a country. And you can this is really wordy. I'm kind of going right from the book here. But again, the explanatory variable is the average income, because the amount of money people have to spend on healthcare helps explain the average lifespan in a country. Again, the more money you have, more than likely you're going to live longer, because you can afford better food and afford better healthcare, see doctors whenever things are wrong. Okay, so look at example B here. It says the heights of husbands and the heights of wives in a sample of married couple. So this is one of those examples where there's not really an explanatory variable. Just because a husband is tall doesn't necessarily mean that a wife is going to be tall or their wife is going to be short. There could be couples where the wife is taller than the husband's taller than the wife, they're the same size. So this is one of those where the explanatory variable could be either the heights. So for B, the explanatory variable could be either the heights of husbands or the heights of wives. Because either variable. So again, a little bit wordy, okay, could be used to explain the other. Could be used to predict or explain. Okay, again, you could have a random 100 group of husbands that are all taller than their wives, who all said they wanted their wife to be shorter. You could have a random group of people that had the wives are taller because they like shorter men. It's just this explanatory variable could be either. You can't tell which is which. Okay, so that's example one and objective one. Objective two is to make a scatter plot to display the relationship between two quantitative variables, faster and further. In this example, here are the 40-yard dash times in seconds and long jump distances in inches for a small class of 12 students. Make a scatter plot to display the relationship between 40-yard dash times and long jump distances. So when we make a scatter plot, again, we're going to use the math applet. Okay, and we've got to understand what we're dealing with here, what our association is. For this problem right here, we're looking at the dash time as my x or my explanatory, and the long jump distance y is my response. So you have to imagine that running track, before you do your long jump, you run. The faster you run, the further you're going to jump. So the faster your time is actually the shorter amount of time. So we're going to enter this into the stats applet. Okay. And again, we want to make sure we label the axes. So you want to make sure that you take a picture of this. We're going to go to the stats applet. And again, we are in two quantitative variables now. So this is going to pop up. And what's our explanatory? We have dash time. So again, our 40-yard dash time, and that's in seconds. And then our response was the long jump distance. And that was in inches. Okay. So we have to make sure that we put these in the same order. These are ordered pairs, remember? So I'm going to list all of my X's, and in the same exact order, I'm going to list all of my Y's. So I have 5.41, 5.05, 7.01, 7.17, 6.73. Again, just make sure you're typing this in correct when I ask you to make a scatter plot. 5.68, 5.78, 6.31, and 7.25. I'm going to go down to my response variables or my Y values, and I got 171 inches, 184, 90. And again, you've got to make sure that you type these in the same order, or else your ordered pairs will be all over the place and your data will not match what it should. So just make sure you take a picture of this and you copy everything correctly. You can always go back and count. And make sure you have the same number on top and the same number on bottom. So again, I've got how many x's? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which I should. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so now I can go ahead and begin analysis. I want my scatter plot. This is what I'm looking for right here. So we're going to go ahead and I'm just going to copy this, put it into my notes. And right here is my scatter plot. So we have to be able to make this scatter plot. We're going to talk about the association or the correlation in the next objective. But you should be able to tell me by looking at this whether this is a positive or negative correlation. Because it's going down, we would say this has a negative correlation. But we're going to get into that in the next objective. Okay. So be able to use the stats applet. Make sure you know your response variable and your explanatory variable. Objective 3. So this is really important right here. You need to write these 4 things down. Anytime that I ask you to describe the direction, form, and strength of a relationship displayed and any outliers, these are what I'm asking you to do. Okay, so how to describe a scatter plot. I'm going to specifically look for, do you give me the direction? Okay, so if it has a positive association, again, a positive association, a lot of times as we go from left to right, it gets larger. Okay. A negative association, as we go from left to right, it gets smaller. Okay. And then there's no association. So if the data is kind of all over the place on a scatter plot, there would be no association. Okay. The type, the form, is it linear or is it nonlinear? Now, it's not going to form a perfect line. Okay. If it does, that would be really, really, really strong correlation or strong association. But is it linear? So we may have some that look like this with a scatter plot, and we could come to a conclusion that, yeah, I could draw a line through that. So we would say that's linear. We may have some that look like this, where the dots are kind of going, and that doesn't necessarily form a line. So we would say that's nonlinear. Okay, strength. Is it weak, moderate, or strong? How far do the points deviate from the actual line or the nonlinear form that is being formed? Okay, the further away from the line or the form, then the weaker the strength is. If it forms an exact straight line, we would say it's strong. A lot of things that we deal with will be moderate because they're they're not forming an exact line, but they're kind of, you could draw a line through it or a line of best fit, as we talked in algebra. But they don't all fit exactly on. And are there any outliers? Are there anything that's way outside the overall pattern? So again, really, really, really important. Direction, I'm talking positive, negative, no association. Form, is it linear, nonlinear? Strength, weak, moderate, or strong? And we're going to continue to work with this throughout this chapter. And then are there any outliers? Are there any points that are way off the beaten path when it comes to the actual form that it is making? So let's take a look at a couple of examples. And we'll go back to that very first slide that dealt with the weight and the price. Okay. So for this example right here, when we make the scatter plot, okay, the very first thing that I'm looking for, and then I'm going to ask you to find, to describe, again, when I ask you to describe the relationship, I'm looking for 4 things. I want to know the direction. Okay. What is the direction? So for this first one, the direction would be positive. Okay. So we would say that this has a positive association. And again, we're going to kind of spell this out. There's a positive association between, let me spell this right, the weight in carats and price of diamonds. Right? Okay. So the heavier the diamond, the more it's worth. Number 2, the second thing that I want you to tell me is, what is the form? So this form right here, if I were to draw a form through this, I would say that is not linear. Okay, that does not form a line, so we would say nonlinear. boy. So the form there is nonlinear. Okay, there's a curved nonlinear pattern, so you could say it's curved. The third thing that I'm looking for when I ask you to describe it is the strength. For this, I would say that this is a pretty strong um, association. So this is a strong association because all of these points are really, 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 really close to the dot or to the form that we drew through this. They're all really close and tight. Okay, so when we draw the form, we would say this is the association has a, I would say, strong association. And then the fourth thing is the outliers. So when we're looking at outliers, really there's not any. You could maybe say this. And again, we're going to have a way to find if it is an outlier. That we talked about that in chapter 1. But if I did say this was an outlier, I would say that at about 3.6 carats, and the cost would be what looks like 210, 215, $215,000 would be the outlier for that. Okay, so looking at that first example, there's the 4 things that I'm looking for. We're going to jump up here for the second example. Very first thing is direction. What does it have? That has a negative correlation or a negative association. So for the second one, we would say negative correlation or negative association, which means what? Which means there's a negative association between the dash time and long jump distance. So a negative association between, I'll go ahead and write it out, the dash time and long jump distance. Right? The slower you are, the less likely you are to have a longer jump. Okay? So, students with longer dash times, students with longer dash times tended to have shorter distances. Again, that should make sense. The faster you are, the further you're going to jump. The slower you are, the less likely you are to jump further. Okay, so the second thing is the form. I would say that this right here is linear, right? This is a linear form. Okay, because it follows a straight line. What's the strength? I would say this is moderate. Okay, moderate because the point's somewhat formed, so the association has moderate strength. And then are there any outliers? There really don't appear to be any that are way off the beaten path there. So fourth thing is outliers. And I would say none. There don't appear to be any. So 2.2 scatter plots. Make sure that you can understand the association. Do they form? What direction they go in? Positive, negative, or is there no association? Do they form a linear, nonlinear, curved function? Can you tell me the strength? How far away from the form that are the dots? And then are there any outliers? All right, so you have a little elastic assignment over scatter plots and 2 variable quantitative data.